All right, let's get this ball rolling. Today we're going to explore a question that I frequently get from my residential clients when they're considering a home addition project. Should we build up or should we build out? Hi there, it's Drew here, architect and owner at Hemisphere Architecture LLC. So I've done it both ways, both building up and building out. And I wanted to share some of my insights with you from my experiences of both of those that might better help inform your own decision-making process. We're going to look at the pros and cons of each. Unfortunately, in the end, I won't be able to conclude that one is better than the other for you. Since every project is a prototype, you're going to have to work that out with your own team and work with your specific problems. So I'll try to keep these points generic, and you can factor them into your own decision-making process. So let's get into it. All right, so let's start with some extra generic diagrams that I've got here sketched up on the screen. I've got three building sections for illustration. In the middle here, we've got an existing conditions diagram. On the left, we've got a building up diagram. And on the right, we've got a building out diagram. So that's how we're going to proceed. So let's start with building up and the pros. The first pro we've got here should be pretty clear that you're going to have the smallest footprint in building directly on top of your house. You're just stacking on what you already have, so it's the most compact on your property. So you're going to save the most yard space in this option. The second pro is less foundation and excavation. We're saving all that excavation from building outward here. So the concept here is that you're trying to get more value out of reusing your existing foundation. And the last pro here is stairs like to stack. So let me explain this in a little bit more detail with the existing conditions diagram. So in this diagram, I'm showing a stair down from a first floor down to a basement, which is pretty common in Pittsburgh here. So in this example here, we really can't use this area on the first floor for much else in your floor plan. It's a hole in your floor. That is, you can't use it for much anything else except for another stair. So if we go into this building up option, we've got this stair stacked directly on top of it. So there's some efficiency in stacking stairs on top of each other, as opposed to having, that existing stair going into your basement and then a completely separate stair somewhere else going up onto your new second floor above it. So let's move on to building up and some of the cons associated with those. And the first point here is that stairs may not like to stack perfectly, and that's connected to the last point that stairs do like to stack well, not 100% perfectly. And that's sort of because your existing stairs may not be built to code. I see it all the time. They may be too steep. There's too much rise over run just to save some space in the floor plan, or they may be too narrow. And that's fine. You're not obligated to bring them up to code unless you plan on totally rebuilding them. But your new stairs do have to meet building code. So they may have to be wider than your old stair, and they may not fit within the same footprint of that existing stair. They need to be longer to correct that rise and run slope issue. And your stair up to the second floor may be longer just because it's a taller floor, in which case you may need to get creative and have a landing or a turn to make it work within your floor plan. The second con is a structural unknown. Your existing foundations, because you're building on top of it, you're hoping that the existing foundations have the capacity to support a full second story. But unfortunately, hope is not a strategy. It makes a lot of sense that your house was not built that strong to support a second story. It doesn't really make a lot of sense that somebody would build this original existing house with that capacity with no intention of actually building it. So it'd be wasted money from the outset. But also your foundation's maybe 50 years old, 100 years old and falling apart. And the issue is you can't see a lot of it because it's underground. And what you're going to have to do is excavate down to the footings and see what you have just to evaluate it. You may have an old stone rubble foundation and no concrete footing at all. And even if you do find a footing down here, we're not going to know just by looking at it if it's reinforced with rebar. So you may have to actually chop some of this footing up to see what's inside of it. And at some point, if you start doing all this work, you're defeating yourself by doing all this excavation and analysis. But it may be required. So some of the solutions that we've used to deal with this is mostly a separate gravity structure that we know can support this full second story. And what some of the conditions that we normally deal with are we'll have some new framing going across this second floor, and there may be beams, LVLs or pieces of steel that come to the perimeter of the building. And often what we have got to do is embed posts within this wall here, and to support that point load and bring that point load all the way down to the foundation. So if you've got a CMU, concrete masonry foundation, then that point load's got to continue through it. And sometimes what we have to do is fill those cells with grout and rebar to reinforce it. This could also mean embedding posts in the interior of your floor plan. If you've got a beam that's stopping somewhere within the perimeter of your footprint, then you've got to have again a point load path that is transferring that end of the beam all the way down through your first floor, through your basement, and all the way into your slab. So what that means is cutting a hole in your existing basement floor slab, casting a new pad, a concrete footing that's going to support that post. So the issue here is that your foundation may not be good enough, and the scope of work to correct it might go through areas that you didn't expect, going through the first floor, going through the basement and into your slab, which could add more cost than you initially had anticipated. The third point is sticking with a structural issue that you may have, and that's the unknowns for your lateral resistance, and that's your building's ability to resist racking and wind loads. And we may not know how your building is doing that, if at all. So most newer homes use exterior sheathing as lateral resistance, and that's either OSB or plywood that's affixed to your exterior studs to prevent that racking. But maybe your house just has a rigid insulation board on instead of sheathing, which is providing no lateral resistance at all. Or maybe you just have some sheathing at the corners of your building, which is pretty common that builders do that to save a couple bucks. Or there could just be some diagonal bracing in the stud framing. You see that instead of sheathing, there's actual sections of stud that are running diagonally within the framing section. Again, we're getting into a situation where you have to open up walls and find out for sure what's there. We can't guess that something's going to work if we can't even see it. So you're spending money to at least explore it. And it's a real possibility that you may need to add some lateral resistance to your first floor in order to support the second floor laterally. And that could be a lot of things. It could be a new shear wall. It could be new sheathing on your building, maybe opening up and adding some of this diagonal bracing to your exterior studs. But just like point number 2, this may be more cost and work in areas that you just didn't originally expect. The next point, number 4, is about saving your ceilings. You may be tempted to think, hey, we're only building up, right? We can save these ceilings and just do all the work on top of it. Well, that's a real coin toss. Maybe you can, but I would budget time and money on actually having them completely rebuilt. They may just be a casualty of removing your roof. If we go to your existing house diagram here, and assuming you've got prefabricated truss here, trusses made out of 2x4s, you'd be coming across here, sawing out the web members, and trying to save the bottom core of the truss that has your ceiling affixed to it. But with all the structure gone, you're going to end up building temporary walls or some sort of temporary measure to continue to hold them up, or you're going to have to slide in sister framing along the bottom chord of that to keep it up. It's a lot of effort, and it might not work for you. Plus, you've got plumbing and other systems that you're integrating above it that you could end up chopping up the ceiling to such a degree that it's not worth saving and be cheaper and faster just to build a new ceiling. Um, so that's about the ceilings. Point number 5 here is about, again, roof removal. It's sort of just a reminder about cost. You're not just building a new roof here. You're paying to remove an old one. Demolition costs money as well. So I've seen people try to salvage their existing roof, either just the trusses or the entire thing as a whole. That may work for you. It may not. It's just going to be a more sure shot thing to count on buying a completely new roof. So it's a double dip on costs of removing and adding a new one. Continuing with the idea of your roof here, and point number 6 is the speed in which you are building your new roof. You can imagine that once your roof is gone, you are on the clock for how long you are you're taking to build a new roof and protect the contents of your house. Even when you see roofing crews up there just doing reshingling work, there's 5 or 6 guys up there, depending on the size of the roof project, and they're flying through it because they want to get it done in one day and not risk leaving your roof off even for one night. So you can imagine that once your roof is gone, you're going to be watching the radar, watching the weather, not sleeping at night thinking, wow, there's still not a roof on my house. So some ideas that I've seen to get ahead of this are either having prefabricated trusses. They're sitting in your yard on site, ready to go, ready to be craned up as soon as these walls are up to support it. Or you could do a sort of a quick phased sort of approach where you're only demoing and rebuilding one section of your roof at a time to avoid a total exposure of your house at any given moment. But that's something you have to discuss with your contractor. It's a means and method issue. It's not actually a design issue. It's about how it's being done along the way. The next point, number 7, has to do with HVAC in your attic. And you can imagine if you're adding a full second story on your first floor, you're adding a lot of volume. And it's very likely that your existing HVAC system will not have the capacity to both heat and cool that volume of space. So one of those ways to get around that is a completely separate HVAC system in your attic. And so that would be a top-down feeding approach. And there's a couple of considerations with that sort of approach. The first one is insulation. You'll see that in this existing house diagram, you've got all the insulation in your ceiling plane, and that's the boundary of your thermal envelope is that box. Now, that wouldn't exactly work if you've got HVAC in your attic. You have to have your equipment and your ducts within the thermal envelope of your building as to not be wasting energy into the environment. So without putting insulation on this plane, you're putting it directly to the underside of the deck. And in this area, we need R49 insulation to meet code. And for a condition like this, it's very likely we're going to be talking about a spray foam insulation. And there's a lot of special attention you'd have to do to pay to correctly vent this type of assembly, but that's a different discussion than for here. Point number 8 here is moving out. I would absolutely recommend that you move out for the duration of this project. Remember, you won't have a roof for some period, no insulation. Your ceilings may be coming down, tradespeople coming and going, accidents, circular saws falling through your ceiling. It's not safe. You got to move out. The next point is hand in hand with that. Number 9, protecting your interiors. Again, we're talking about chance of inclement weather, getting into your house, debris falling inside. And you've got all your valuables inside your house, your furniture, your belongings. It's worth considering pulling some of that out and putting it into storage short term, or otherwise protecting them from damage somehow. And the last con here is a generic one that has to do with almost every interior project, and that's finding more problems. It applies to every project that's a renovation at all. You can accidentally run into problems that you have to fix along the way. Maybe you find an area of rotted framing that must be replaced, leaking plumbing, it's got to be replaced. Well, that's a change order. And that's going to be tacked onto your bottom line and your budget. So you should anticipate some of this and carry a healthy contingency in your budget so that that money is already waiting for that potential outcome. So those are some of the considerations of building up. So let's move over to building out and start looking at some of the pros here. And we're talking about building out, we're talking about an adjacent addition, as this diagram suggests, connected to your existing house, not on top of it. So the first pro here is the likelihood of you isolating your new work, as opposed to building up where there's a lot of existing house below that can be sucked into your scope. Building out will affect less of your existing house. You may be able to cordon off the work and start building some of this addition without touching any of the interior space of your house. You might be able to build nearly the entire addition and only punch a connection point at the very last steps of construction. So we're really limiting and isolating this work. I'll make point number 2 as maybe not moving out or limiting your move out time as compared to building up. Again, you may be able to stay in your house longer because you're doing a lot of isolated work. Although you've got to talk with your builder about this. There's still a lot of downsides about living next to a construction project, safety concerns, especially if you've got pets and kids. Point number 3 next is less demolition. Again, you're still cutting some holes laterally connect your addition to your existing house, but it's far less than building up. You're not necessarily going to be removing large sections of your roof, and depending on your roof geometry, you might be able to build right on top of your existing roof for some sections of it, like this diagram is suggesting, and not tear that much off. Number 4 is less chance of surprises, and this corresponded to the last point of building up. But with opening up fewer walls in your existing house, you'll find less to fix, and this is kind of a case of ignorance is bliss. Problems may exist in your existing house, but if you don't see them and you don't know about them and they're not going to affect this project, then they're not going to get sucked into the effort and the cost at this time. So that's a benefit. And the last pro of building out is more HVAC options. So you could still consider the idea of putting a new HVAC system in your new attic, again, because you're adding a lot of volume. But you've got some other options too. You could put a new HVAC equipment in your new basement. You could put some new equipment in your existing basement, and then have ductwork go laterally into the new addition through a new hole in your basement. All right, so let's move over to building out cons. And the first one should be clear that you're going to be spending some more money on foundation work in this type of project. You're going to have some choices. You could either do a full basement under your addition. You could do a crawl space. You could do a slab on grade if you're planning on a garage addition, for example. Typical foundations around here are CMU walls, cast in place concrete on concrete footings, maybe even a precast concrete wall system. There's some more exotic systems out there, but these are just the most common. And there's a decent amount of cost and effort associated with new foundations, such as excavation, formwork, waterproofing, insulation, site drainage, so on. So, and one final point about your foundation is please do your best to avoid building a foundation or a basement that is lower than your existing basement. You can open a real can of worms here and end up having to do something really expensive called underpinning, where you're actually undermining your existing foundation. So don't go lower than what you already have. It's very expensive. Just don't do that. So the second con here is don't build on fill, and it's related to foundations in point number 1. And to explain this point, let's slide over to the existing house here and talk about how your foundation and your basement was originally constructed. So we've got this highlighted section of earth here, and that is, we're going to call that the undisturbed earth that was never part of the project at all. And what happened was your excavator came and dug a hole and around the footprint of your house. And it's very unlikely that it was the exact shape of your basement. It was overdug, and it had this angle of repose here that sloped here just to prevent the hole from collapsing. And then your foundation was built, your basement was built, and then around your whole house, this was filled back in. Maybe it was compacted, maybe it was not, we don't know. But with this knowledge, we know about something that we should avoid, and that is building directly on fill. So assuming that we still have this fill section around your house, um, you could make the mistake of just starting your foundation right at the frost line. And around Pittsburgh, our frost line's 36 inches. So you'd be tempted to think, well, I just need to go 36 inches and shoot straight across, and that's perfect. Well, no, not exactly. Here you're building on fill, and there's a big risk about that, and it's that it could cause settling, cracking, shifting. An existing or a new foundation here can actually cause lateral pressure against your existing basement foundation wall and cause it to bow and crack. So it's actually, the code says not to do it either. So there's a lot of reasons not to do that. But what you could do is, what you have to do is start by, whenever you're building directly adjacent to your existing basement here, is to start all the way down at the bottom with your existing footing and actually have to step up your footing until you reach that frost line that is in the undisturbed section of your foundation. But my point here is, and why I'm showing a basement here, is that with all this work, you're actually going through a lot of the steps to create a full basement anyway. If you're just planning on doing a slab on grade addition, assuming that it's not for a garage for that extra load, and you've got this, this step footing that's a lot of foundation work anyway, it kind of makes sense. It's sort of efficient to just finish it off and get some extra usable space out of all that work and all that money that you're otherwise not going to be able to see. So that's my recommendation for not building on fill, is to make it count. The next con, number 3, again, should be pretty clear that it's eating up more yard. And for some people, this is just a non-starter. You might have a pool, a big tree, a setback limitation on your property, some other obstacle, and you're just not going to be able to build out like this. So if it's not available to you, you're out of luck. Point number 4 is more area in your basement. This can be a design issue. It may be a negative. I'm showing it as a negative, but it's that the basement sort of might be an afterthought. Like I had suggested, it's just, you're kind of already building it anyway, so it might not be as useful to you. Less available windows, less available doors, and egress out to grade. So it may not be the most valuable space that you were anticipating on using. And the last point here of building out cons number 5 is the layout could be more sprawling as opposed to going up. And again, it might be a good or bad thing based on your layout and what you want to achieve. If you want a grouping of bedrooms to stay together, then building another full story above may make more sense for your project. If you need several bedrooms, putting some in the basement and some on the first floor, it just might not be the way you want to use all of your new square footage, and may not make sense for you. If you just want a first floor in-law suite or garage or building out, makes a lot of sense in that type of project. So it really has to do with selecting a layout and having the adjacencies work for how you want to live in your house. So that's a high-level look of the pros and cons of building up versus building out. As I said before, you may run into some of these issues, you may not. Your project will have its own set of objectives and constraints, so there is no right answer for your project. The takeaway here should really be that you should do your appropriate homework. Get your architect, your engineer, and your builder all together and listen to the concerns, and try to come up with solutions as a team together. So that's all for today. This is Drew from Hemisphere Architecture. Until next time.